from IlkkaVaisanen from Finland.
Yes.
I hope I spelled your name right.
Yeah.
So sorry about
Good
this.
enough.
So he studied at the University of Oulu in the Department of Mechanical Engineering, and yeah, he will give us a view on his presentation now.
Setting up my timer here. So, thank you for being here. I'm very pleased. Good morning, everybody. So, the topic of today is my diploma thesis, which I made for the tire company. And basically, my research question was how to test tire differences so that they would be reliable and repeatable and easily readable, the results. And I was given two sets of tires, tire A and B. The tread pattern was the same, but chord angles and rubber mixture was a little bit different between them. So I had to figure out the methods and measurement parameters for these. So my approach was to use ISO standards. The first one was constant radius test with 30 meters radius, and the next test was to use step steer to have some kind of idea of the response of the vehicle or the tires. And the last test was a safety test, obstacle avoidance, and to have a repeatable test, we used a robot-controlled vehicle with measurement unit, and the measurement unit measured these values, which are commonly known from B-cycle model: lateral acceleration, vehicle speed, and steering angle, yaw angle, and side slip angle also. And at the end, we didn't have loads of measurement data, and we had to fit the data, filter, and make the calculations, the error calculations. And next I present the results of each test cases. So next three lights are from constant radius. So we have heard about this self-steering gradient earlier. So basically what we did here, I divided this section for non-linear and linear part and calculated the slope values and made a comparison between the tires. So we can see that tire A has a little bit higher K value here. And the next thing is yaw velocity gain. And we wanted to find out the sensitivity of the tire as a function of speed. And here we just monitored the characteristic velocity. And from there we made a comparison between the canes, and you can see that tire B is a little bit more sensitive for steering at this speed. And the last part for the constant radius was the vehicle slip angle as a function of lateral acceleration and backward calculation based on the fact here when the car has a zero slip angle, side slip angle, we were able to calculate the cornering stiffness, and once again we made a comparison between them, and it seems that tire B has higher corner stiffness than A. And step steer we did with 3 different angles, and these corresponds 4, 6 and 8 as a lateral acceleration, meters per second square, but we didn't find out big differences, so here's just one slide, and at the end we think that results was the same. The rise times, rise maximums, overshoot values, and gains was pretty much the same between the tires. And the last test was about the obstacle avoidance. So we programmed the vehicle go through the test track, and also we monitored the path following error, and tires were behaving quite good in that sense. But here, we monitored basically the steering wheel angle, and we made a quadratic or integrated over the time the steering wheel angle, and we got the work load that it is needed to drive through the track. So it shows that it needs, tire A needs 4% more steering work. So the conclusions, I think that we were able to find out tests and test methods that are easily repeatable, and hopefully they are reliable also. And for the R&D, I think that these numbers that I gave can easily read and can be compared when the R&D is designing the tires. And so the summary of the tires: tire A feels like more understeering for the driver, based on the Bergman theory, and B is just a little bit more sensitive for steering, and the cornering stiffness of the tire B is higher. That means that the rear axle is stiffer in cornering of steady-state situations, and tire A need more work, as it could be seen from the obstacle avoidance test. But both tires were acting logically, and I think they're safe and predictable tires. So the tire B is more fun to drive and react faster for the handling. So basically we used objective methods, and we analyzed them based on the subjective idea. And on that bombshell, it's my time to end. Thank you very much.
Thank you, Ilkka, for your inside view in your diploma thesis, and I think it's nice at the end when you can see that the objective data fits to the subjective impression, and that's what subjective objective correlation goal should be. Yeah?
Yeah.
Next presentation will be about recyclability, so not directly that much linked to subjective objective correlation, but nevertheless very important, and I'm interested in the presentation from Anton Tomasov. He's studied at the let me have a look at